So mathematically, we still need to use the distributive property combined with our exponent laws. So your step 1 is multiply the coefficients together. And step 2, when you multiply the variables together, add the exponents of the like bases. So that's determined in this situation. So this last question here, remembering that if you don't have any exponents, it's just, or any exponents on your numbers or on the variables, then it just means 1. So for example, if we do a really simple example, I'll just do it at the very bottom here, is if we took 3d times 2d, we would multiply those coefficients together. That would give us 6, and when we multiply the d's together, it's the same as saying multiplied by, just fix this, it's the same as saying times d 1 plus 1, because in a situation with no variable or no exponent on those variables, we assume that it's a 1. So this becomes 1 plus 1, which then is 6d squared. Right? So that I'm going to take this off, but just want to give you guys that as an example. So what we're looking at then, and we're going to do these on the other page, but when we look at these ones here, we'll just simply rewrite. And the only one that we really need to be concerned with, what's being spoken of in step 2, is part 4 here. Now what that should actually read, because like I said, is it translates into your, this translates into a PDF style format on the program that I'm using. It tends to make the exponents into a large coefficient size. So what this would actually read is 2k multiplied by 3k to the 5 minus 4k squared plus 7k minus 4. So that would be the whole polynomial in that situation. So yes, we're going above trinomials in this situation, but don't worry, I think you guys can handle it. Remember, you just have to do things step by step. We're not going to solve them on this page. We're going to solve them on the next page. So here we are. So again, to translate, I will have to put the polynomials or the exponents on each of the polynomials terms, just so you guys can see it more clearly. All right, so what happens when you take 3d and multiply times 6d plus 4? Again, you have to distribute each of these, and 3d has to be distributed to each of the numbers. So if we take 3 times 6, that will give us 18. D times d is the same as saying d of 1 plus, d of 1 plus 1. And being that 3 is positive and 4 is positive, will be plus, and 3 times 4 is 12, and we have to carry the d through, so plus 12d. So we end up with, as our final answer here, 18d squared plus 12d. So that's going to be our answer for the top one. Let's take a look at the next one. So now we have negative v multiplied by a positive v. So let's rewrite this so that we can see things. So I'm going to put a line divider there. So we have negative 5 is being multiplied by negative v out front, and negative 5, let's just write this a little clearer. So we have negative 5, or negative v, sorry, multiplied by negative 5v plus 8. So we have to distribute the negative to each of these terms. So being that the v variable is negative, that is going to make the negative 5v, the whole polynomial or the whole monomial or term, into a positive. So even though it's just a variable out front, that negative goes through and carries through the multiplication. So what we're going to end up with is 5 8v squared. And then we have a negative times a positive will be minus 8v. So we have negative 5v squared minus 8v in that one. The next one we will bring down here. So we're going to solve that one here, and then this one will drop right down to solve that one. Just give it some distance. So now we have 4y minus 1 multiplied by negative 2x. So we've just shifted the monomial to the position at the back of the equation or the multiplication sentence rather than at the front. That doesn't make any difference. You can just still simply distribute it into the brackets. So here we'll multiply negative 2x, and the thing that you need to be cognizant of or be aware of is that we have a negative term here. So don't forget about that just because you shift positions. So now we have negative 2 times 4 will give us negative 8. Now, here we also have a little bit of a change up. Now we have x and y. We don't have, so we have an x here and a y here, jumping a little bit up here. So that's what we're looking up in the actual written equation. So what do we end up with? So because we can't combine variables that are different, we just simply carry through and we write them as if they're multiplying. So we get negative xy. And normal convention is to write them alphabetically, so the x will come before the y. And then we're going to multiply the negative 2x. The y is not on the 1, so we don't have to do anything with the y, and what we end up with is, so negative 2 times the negative 1 will become positive 2, and that x also comes through, and so this will be our final phrase. So it's negative 8xy plus 2x. That's how they ended up with the answer shown behind the question. Now we're going to take a different jump here and work with numbers that are a little bit bigger. So what we end up with here is we have 2k being multiplied by 3k to the 5th minus 4k squared plus 7k minus 4. What we'll end up doing here now is we still have to distribute in the same sort of manner. So what we're going to do is, for the first term, we will take 2 times 3, which is 6, and we multiply k, and remember we assume that that's a 1, so it'll be the same as 6k 1 plus 5. Being that this is positive, we're not going to get any changes to our functions or symbols, so this still becomes minus. Then we have 2 times 4, so that's 8. And we have k 1 plus 2. Oops. There, that should be a 1. Plus 2 times 7. And 2 times 7 is 14, so we go to this one here. Is 14. And k, both of these having no exponent on them would be as if it's 1 plus 1. And then minus 4. So we distribute to the last number here. And we get minus 4. That minus 4 then becomes minus 8. And the k will carry through for minus 8k. So then if we go and we finish up by combining our exponents to end up with the last final number, we'll end up with 6k to the 6 minus 8k cubed, or to the 3, plus 14k squared minus 8k. There seems to be a typo in this answer. That's not right. So that's what we should end up with here as our final answer. Right like that.